So this week's all about flow control. You guys have gotten to a point where you can write little pieces of code. You can at least get some print statements going. You can get some input statements going. But now we kind of got to get Python to further understand what we want to do with it. So we need to execute certain codes under certain conditions. If it's something, then we need to do something else. And so that all relates to flow control. If you look at this diagram here, this is a common flow chart in which, in this case, the program starts. It asks, is it raining? And then depending on whether that's a yes or a no, you have different outputs that go along with there. So if it's yes, it checks to see if you have an umbrella. You have the options of yes and no. If no, then you get an option to wait a while. Then it starts back over if it's raining and starts the loop back over. Right? In order to determine these type of yes or no answers, we have to go back with very simple choices of Boolean values. And so Boolean values are another data type, right? Remember the data type from last week? We had our integers, we had our floating points, and we had our strings. So Boolean itself is another data type, and it only has two values. It's either true or it's false. You'll notice that in the true and false portion that it's a capital T and a capital F. That makes a difference in Python. All right. So the idea behind capital T and capital F is you setting whether or not that value is true. So if we say something like spam equals true, it's equal to the value of true. Again, it's not the same thing as a lowercase t. You will get an error coming back saying that's not defined. And you would check to see if something works, right? So to do this, you'll have to use comparison operators. This is similar to like the math operators that you used before, where you were using addition, subtraction, etc. We now have what's called comparison operators or relational operators. And the idea is that we're going to compare two values and then evaluate it down to a single Boolean value. So for example, we can say if 42 is double equal to 42, we would get back true. If 42 is double equal to 99, then we get back false. Note that you have to use two equal signs if you want to check for equal to. If we use a single equal sign, well, then we're back to last week, and that's actually assigning that value. So if I say 42 equal 42, that just means 42 equals 42. We're assigning the value to it. All right. Not equal to is the exclamation point in front of an equal sign. It's important that you get these in the right order. Less than, greater than, and then you have less than or equal to or greater than or equal to, right? Most of you have done this simple type of math at some point, but this doesn't just deal with integers, right? We can test strings to see whether or not they equal what we would expect them to equal. All right. This little section here, again, is just a reminder that a double equal sign is going to check whether something's equal to. A single equal sign is going to actually assign the value. When you start working with if statements and things like that, which we're going to work with here today, it's easy to forget that second equal sign. Your code will sometimes work, and then other times it just doesn't seem to work right. You probably put in the wrong one. Just make sure you have double equal signs. All right. Along with your Boolean values, you have Boolean operators, and those operators are used to compare two Boolean values. So we have and, or, and not. That is not the same as not equal to and all the ones we talked about before. These are Boolean operators, meaning that we are checking to see if it compares to another Boolean operator. So what does that mean? We can check to see if something's true and true, meaning that we can test an equation to see if it's true. We're also checking to make sure the second equation is true. And if that is true and true, then it's going ahead and going to do the true result of that. It's a way for us to test two things on the same line. And there's a reason to test a thing on the same line is that you want to make sure both conditions are met before you actually execute the code below it. You can also use or, in which case it would check for either this condition works or that condition works, and either one of those relates down to a true. Those end up being what's called a truth table. And so for the and truth table, if it's true and true, it's true. If it's true and false, it's false. False and true is false, and false and false is false. Okay. Or slightly different in that if it's true or true, it's true. It's true or false, it's true. And if it's false or true, it's true. False and false is false. right? All this means is when we're running these different operators, and we're going to show you some examples of those, that if any one of those values, because you have or is there, if it equals or has a chance of equaling true, it's true, right? The not operator is very simple. It's just the opposite of whatever's in front of it, right? So if we want not true, we end up with false. If we say it's not true, it's true. Anybody got any questions on that? How that works? All right. So if we look at some of these examples, it would be something like this. Remember, in parentheses is the code we're going to execute first. So if 4 is less than 5, that would be what? True or false? True, right? Then we're going to check this one, that 5 is less than 6, which is also, and therefore true, and true is going to give us true. All right. Similar to when we use an or, is 1 equal to 2? That would be a false. If 2 is equal to 2, that's a true. But because we're testing whether it's false or true, in this case it's true, we would get true out as the value, and we would test that theory. All right. When we're working with flow control, we always have a condition, which means we are setting up some kind of equation, some kind of condition, and it's usually in a block of code, which is called a clause. All right, so we have to give it some kind of condition. If that condition is met as true, then we hit this other block of code. If it's false, we hit another block of code. All right. When we work with blocks of code, Python is very particular in this, in that the blocks begin when the indentation increases. Blocks can contain other blocks, and blocks will end when the indentation decreases all the way to 0. Or to the containing blocks indentation. So what does that all mean? If we look at this piece of code here with Mary, we say the name is equal to Mary, the password is equal to swordfish, and if name double equals sign Mary, so we're checking to see if name in this program is currently set to Mary, right? Then we'll notice we have our first indentation. That means that any code here is only going to run in the event that Mary is true. In this case, if name equals Mary is true, then we run this code below it. If name was set equal to Susan, it wouldn't matter. We would not run any of this code underneath of it. All right. Then it's going to go ahead and print hello Mary. We then have another block of code under here, which is going to check if the password is set to swordfish. If it is, we go ahead and run this line of code. In this case, we're going to use an else statement, which means if it's not true, run this piece of code, in which case we're going to print wrong password. Right? This block here ends at this last line when it has now reached the end of the line and gone back out to the outside indentation. If we look at this block of code where this one starts, it runs print. At the moment this print statement ends, it now returns down here at the bottom, which goes clear back over here to the left. So after this print access granted is executed, we won't execute this code because that's only happened if this was set to anything other than true. In this case, password is equal to swordfish. Therefore, this is going to equal print access granted. All right. If we played with idle a little bit, we saw how this worked in code. So if name is equal to Jason, my password is equal to Python, then if my name is equal to Jason, then we would print hello Jason. And if the password is equal to Python, we would print access granted. Else, print wrong password. And so if we run this very simple little program, you can see that it ends up matching Jason and it ends up matching Python is my password. If I change this to something else, and then run this. You'll notice this time it comes back with the wrong password because this set to false. Therefore, it's going to go down to the else statement and move on. All right. If we go back to what we had last week, instead of me typing in the name Jason, we could gather a name. And therefore we could check it. So if I type in Jason, I get back still on the wrong password because we're testing that against this. But if we set it back to the original one, it would work just fine. Notice that nothing happens when I type in Jason. Does anybody know why? Lowercase, right?
Okay.
So capitalization matters. So if we come in here, we hit that one. Therefore, we're going to go down to this next if statement and check everything in below. It would be good to have something like an else statement here and say something like print, you must not be Jason. Okay. I spelled Jason correctly. Here we go ahead and run. Type in something else, we get a pint instead of a print. It's a long weekend. There you go. Access granted. All right. This is all flow control. The idea is that we want to test different blocks of code. We want to have some kind of condition met. If that condition meets, we're going to run some code. If it's not that condition, we're going to run a different piece of code. All right. There's different ways to control this flow. And so the one that we've talked about so far are if statements. And if statements, what we're checking to do is, or what we're testing is if the condition's true, we're going to execute the code in the clause below it. All right. It starts off with the if keyword. We have some form of a condition, and that should always express itself down to either true or false. We have a colon, and then the next line after that is an indented block of code. All right. So just like we have here, if name equals Alice, then we print Alice. If that name is equal to anything else, we're not going to execute the code below it. So if you look at a flow control map, you can see here we start. We're going to check to see if the name is equal to Alice. It gets down to a Boolean true or false. If it's true, we run this code. If it's false, it runs down here. All right. These flow charts are kind of handy in the beginning if you write these out, especially as your program starts to get larger. They're not required, but it's handy to do. So to write those flow charts, you'll see a link up here called diagrams.net. You can go out here and create these flow charts. It makes it super easy to kind of build it out just like you see out here in the very beginning, right? I don't require you to do this anymore. However, if you're getting lost in some of your big programs, for example, some of you that are building out your midterm projects and you have like 100 choices, it might make sense to make a little flow chart in the very beginning to figure out what goes where and how. All right. We talked about the else statement. The else statement is optional. Notice that we did not have to have it in our code up above here. So when we tested whether or not it's Jason, we didn't have to have this else, you must not be Jason. If it didn't find that else statement, it just continues on with the program, in which case the program just ended, which is kind of what we saw here. All right. If you choose to have an else statement, it is basically a catch-all. If all the conditions above it didn't catch, this is the one it's going to catch on. All right. The else requires the else keyword, requires the colon after that, and then it goes ahead and indents the block of code below it. Right. So in this case, we have if name equals Alice, print hi Alice, else print hello stranger. Right. Flow chart works the same. You have the ability to use elif statements. So instead of me checking something like this, where I have if my name is Jason, else do something like this. If I wanted to check to see if my name was Alice, instead, I could say if name equals Alice, then go ahead and print hello Alice. And else. If I run this code, I'm going to hit that first else statement, which is a JSON. In this case, I typed the wrong thing. Give me a second. I hit JSON. Notice that I get back, you must not be Jason and you must not be Alice. So this code is going to run this one first. It's going to find that's false, therefore printing this one. Because my name is also not Alice, it's going to print this else statement. It's not exactly handy. It'd be nice to check these names in order. And if that doesn't work, then we say you must not be anybody, right? So if we come up here and we bring this else statement down, we can use an elif here to check if name is equal to Alice. And therefore, if it is, we can go ahead and print Alice this time. We're not going to check Alice's password. We're just going to end the program. We can bring up our else statement and say, you must not be in the list, so to speak. Move this part. Now what it's going to do is first check to see whether my name is Jason. If it's not Jason, it's going to go to Alice. So if I hit Jason, it's going to execute this code here, and then it's going to end the else loop. In other words, this whole elif chain. Notice the moment it prints access granted, it goes down here to the end of the program and ends. We could just put this as end of program. That way we can see it. We can see we just skipped all of this code inside of here because it doesn't need to get executed. All right. If I'm Alice, then it's going to find this first one of Jason, ends up being false. Therefore, it goes to the next elif clause, in which case it matches Alice and prints the hello Alice part. From there, it skips and goes to the end of the program. All right. You can have as many elif statements as you want. So you can have 10 different names that you want to check against. You can also have an else statement. Remember, the else statement is also optional. So I can have 3 or 4 elif statements, never have an else statement. If it doesn't match a condition, nothing happens. Right? You can only have one if statement, right? Unless it's a whole nother chain. And you can only have one else statement if you choose to use it. All right. Anybody have any questions on if and elif chains? Now, if and elif chains can be a little tricky because they always execute in order, right? So it checked for Jason first, and then it checked for Alice. So say I wanted to do something with a name. So I would say, what is your name? We'll go to what is your age? And if we want to check this code down below here, we could say if age, I'm going to change this up here to age, is greater than, say, 18, we can print you are an adult. We can do an elif age is greater than 12 and age is less or greater than, less than 18, or in this case, 20. Then we can print you are a teenager. And we can do an else age is greater than 50. Print you are old. All right. So if we run this little piece of code, we're going to get this in. Does anybody know what's going to happen with this code? Then I didn't type it correctly. Shouldn't be an else. This should be an elif. Does anybody see a problem with this code? So if I type in something over here, say 44, I'm going to get an error, right? The reason I'm getting an error is because remember, anything we take in with an input is always what kind of data type? It's always a string, right? So if it's a string, I cannot compare a string to an integer. This is an integer at this point. I can't do a math operator if it's greater than or less than on strings. I can't test that. So to fix that, I have to do this as an int to change that to an integer. And therefore I need to test that on all of these for age. All right. Let's look at that code. It says, what is my age? I say 44, and it says I'm adult. Is that what we would expect? Code works, right? We run this again, and I say I'm 15, says I'm a teenager. That condition seems to work. If I run this and say I'm 65, notice it says I'm an adult. Does anybody know why this condition is not met? I'm greater than 50. You're right. So because our if chain is going to hit this first one where it says I'm greater than 18, this condition will never get checked in this case. So we have to make sure that we set our conditions in the right order so that what we would expect to happen is at the very top and works its way down. So it's important to have these if-else in the right order. And you need to try to test this code every single time you write something like this, right? So in this case, we would want to check if we're greater than 50 in the beginning and move this up to the top. We could steal this piece of code and put that down here on the 18 part. And so now if I say I'm 44, notice I still reach an adult because it tried this first one, that didn't match. It tried this, it didn't match, and then it found it on this line. Now, if I type in something that doesn't count, in which case I could say 5, notice nothing happens. We don't have a condition for anything that is less than 12 or even 12 years old. We actually type in 12, notice nothing happens. It has to be greater than 12 in order to meet this condition, and it has to be less than 20. So notice we didn't want to put 19 here, and we didn't want to put 13 here, otherwise it wouldn't count. If we wanted to use those numbers, what would we have to do? Yep. Or what other operator could we use? Right. So we could use greater than or equal to 13. Or we could say less than or equal to 19. Either one of those is acceptable. All right. So that kind of gets you started on if and elif chains. If we want to do an else down here at the bottom, we could say else print you are a child. Then we would catch anything else, right? Now, here's the problem. If we think we have everything that's valid, notice we come back down here on what is your age, and I type in -100, and it says I'm a child. So we would still want to write something in our code that would check to see if maybe we're getting valid input, right? And therefore, we need to keep that person answering correctly till they give us something that's even a viable age. -100 doesn't work. Another thing is if I come in here and type this age, and I type in ASDF, you guys might have noticed the program crashes, right? Because ASDF is not a number, therefore I can't convert it to an integer, and the program breaks. We have no way of sanitizing the input from users that come in. So we have another option here called while loops. And what a while loop will do is it will keep executing that block of code over and over again until it meets the clause of that condition for the while loop. Or we break out of that while loop. We have the option to do that as well. So a while loop is going to test as long as that condition is equal to true. Then we go ahead and test it. We have a condition, we have a colon, and then we're going to start a block of code. So from here on out in all of your homework, I expect you guys to sanitize your inputs, meaning if you're asking for an age, you should be getting some kind of age, okay? This gets easier as we go through the semester and we get some better checks. But in this case, if we say, what is your age? And what we're going to say is while true before we gather an input, right? We're going to put our print statement on the inside of that so that we're going to test what is your age. We're going to gather that input. We're going to get rid of this password line for now. And we could say if int, or in this case, if int age is greater than 0 and age is less than 120 is probably the oldest person out there, then we could go ahead and test this other code, right? Everything has to be tabbed into the right alignment. If it's not, it's going to break. There we go. Now, if that works and these are right, we need to put a break in. That's going to help break us out of this while true statement. So we'll break out of there. We'll break when this is valid, break when this is valid, break here. If it does not match that age, we could say else and print that is not a valid age. Please try again. Okay. So now if we run this code, if I type in letters, I'm still going to get the error code because I can't convert this over to an integer right away. All right. We're going to need some other flow statements to help us with that. But we can at least now check to see if we're getting a valid age. So if I say -100, it's at least going to tell me that's not a valid age. And to try again, it immediately starts this loop over. So we have this print, what is your age? Age is equal to input. It ends up not being valid here. Therefore, we hit else and it starts this whole loop over again. All right. Because I said while true, this is going to be an infinite loop. This program will not stop until it meets one of these breaks. So if I type in something like 15 now, it will go ahead and test it. Note that I probably have this error here. It should also be an int. And then the code will run like we expect. 15. It goes ahead and breaks out of the loop and goes on to the next piece of code. All right. So you have if statements, elif statements, and else's. You have while loops. While loops are going to help you sanitize your inputs. So from here on out, you should be using all of your inputs inside of a while loop, testing to see if the input that you wanted is what you expected it to be. If it's not, it should start the user over and over and over. All right. You can also use while statements while you want something to be else. So like here we did while true, right? We could say name equals nothing. We could say while name is equal to, in this case, does not equal Stan. Print what is your name. Then we get the name equal to input. And we can just run this. So what is your age? 15. Now I get what is your name? NCF, and it's just going to keep me in this loop forever. It doesn't matter what I type in, it's going to do it. If I end up typing in Sam, it will end up breaking out of the code. Because at that point, this condition equals false because name does equal Sam, and it will bounce you out of the loop. So you can either use a break to get you out of it, or you can test it this way. But notice I had to define this variable before I could use it inside this condition. I strongly suggest using the while true method versus something like this. But there are times where something like this would make sense. So we could do something like, say, count equals 0. And we could say while count is less than 10. We could say, what is our name? Doesn't matter what we type in, but we say count equals count plus 1. In which case this will run exactly how many times? Count starts at 0. When the condition meets that count is less than 10, how many times would this condition run? So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That's because we started at 0, right? The moment you got to where count is now equal to 10, it is no longer 10 is less than 10, and the program crashes out. In this case, it exits this while loop. All right? Beyond while loops, you can have annoying while loops. So like this is saying here, you set the name equal to nothing. While name does not equal your name, please type in your name. Type in whatever name you want. Doesn't matter unless it equals your name. You're stuck in that code forever. All right. Seems funny until you guys write while loops and then you realize your condition was never exactly set right, and you can't figure out why your code won't break. So those are while loops. We talked about break statements. That's going to help us break out of a while loop. We have continue statements. So by default, if we test this here, where this is not a valid age, we could say continue, in which case it starts the loop on back over itself. Note that continue is not needed here. However, in your homework assignment, I required you to have at least one continue statement. But it will go ahead and either break out of these or it will continue and start the loop back over again. Continue statements are also helpful if it doesn't meet this condition, but it's about to go meet another condition. You can have it just continue on in the block of code. All right. One last loop that we're going to talk about here is called for loops. So the difference between a while loop and a for loop is a for loop typically has a defined number of times you're going to loop through it, right? A while loop could go on forever until that condition equals true, where a for loop is only going to loop through a certain number of times. Okay. We've used other functions in here like the print function, the input function. You guys are now going to be exposed to the range function, all right? So we could say down here at the bottom, get rid of this last one. We can say for I in range of 0 to 10, print I. So what this does is it assigns a variable of I to whatever number comes between 0. So we start at 0, we end at 10. We do not include the number 10. So when I say print I, it's going to print starting at 0 and then go all the way up to 9, but not include the actual 10. All right? Does everybody see that? It's important to know that this starts at this first number. It goes up to this second number, but does not include the second number. All right? There's a third one you can use, which is called a step, in which case it steps by 2. So if I run this, it's essentially going to go 0, 2, 3, or 0, 2, 4, 6, 8, because the next one is 10. It does not count 10. All right, that way you can get odds, you can get evens, you can step in 3, 4, 5, whatever increments you want. It's important to know this, it's on the quiz. All right, so for for loops, we are going through a finite number of times. In this case, we're using the range command. You will use some variable name. We can use I, we can use L, it doesn't matter what we want to assign it. That variable is only valid inside that for loop. So this I is only valid inside my for loop. Now I'm just having to be real simple here and print I. I could do all sorts of stuff with that I, right? And we will in upcoming chapters. So if we look at this, we say print my name is for I in range of 5, print Jimmy 5 times, and it's going to go ahead and print that 5 times. All right. If we just pass it one variable, it's the number, it's going to assume you want to start at 0 and go up to whatever number you give it. In which case the output here would have been Jimmy 0, Jeremy 1, 2, 3, and 4. If you wanted to start at 1, make sure the first one is a 1. Anybody have any questions on for loop? For loops and while loops are very similar. You can write an equivalent while loop. So like I did earlier, if I is less than, or is I equal to 0, while I is less than 5, we just add and increment that up. It works, but it's better to use a for loop because it's more finite in what it's doing, right? Less code, less checks going through there. Again, with that range command, the first one is going to be the starting number. The second one is what we're stopping at. We are going up to, but does not include. And the third one is the stepping argument, meaning how many we want to increment by. If I try to increment by something that doesn't work, for example, if I come up here by 0 to 10 and I want to go by tens, I'm just going to get 0 back, right? After that, I don't get anything else. Because the next one would have been 10. I'm equal to 10. It's past the limit. Anybody got any questions on the for loops? I'm going to assume this is all going really fast for y'all, which is fine. If you got questions, ask questions, because now's a good time to do it. The I is just a variable that you're setting it to. You can set it to anything. In this case, I is going to be, the first time it goes through this loop, it's equal to 0. The second time it's equal to whatever we set it to. So if we just do 0 to 10, first time it's 0, second time it's 1, second time it's 2, 3, 4, 5. We can set this variable to whatever we want. So if I say my variable is Jason, then I can use Jason down here inside. We're just assigning the variable of whatever number comes out of here. Good question. All right, the last part that we're going to cover here today is how to import modules. You guys are going to do this a lot in your programs in the future. So the import that we're going to use today, always at the top of your program. Don't do imports down inside your code. All right, that's bad. Don't do that. Always do your imports at the top of your code. You'll use the word import, and then you're going to import in whatever package you need. So if we import, say, random, that gives us access to the random module, which allows us to randomly generate a bunch of different code. All right. So if you come down here at the bottom and we want to print a random number, we would say something like random.randint, which means we want a random integer. We're going to give it a number to start with and a number to end with. All right. So random integer between 1 and 10. And we're going to tell it to print that integer out, which means it's going to randomly pick a number between 1 and 10. If we run this, in this case, I'm going to comment this code out. You'll notice I get a 5. I run the program again, I get a 1. Again, I get a 3, right? It's a way to randomly generate a number out of your program. Now, in this case, when you're using the number 10, it can actually include that number 10, right? So that's the reason the range command goes up to, but does not include. The random one actually includes from the first one to the last one, including the last one. It's tricky. Yes, it's going to be on the quiz as to what does what. Right? When you're importing modules, there's other ones we'll use down the road. For example, OS. You can use a comma OS. However, it's recommended that you use each one of those on their own line. Right? So if you guys are looking at code on the internet or practicing whatever else, yes, it will take it with a comma. It's best practice to have its own import statement for each one of those. Other ways to do imports, say I just want to be able to use this random integer number. There's a lot of other random modules I can use. To figure those out, if I say random dot, notice that it will pop up with all the different options I have available out of the random module, right? If I just care about this random int, then I can say from random import rand int, in which case now I don't need to put the random in front of this. I can just say print rand int, and it will go ahead and do the code as expected. So if you import as a whole, for example, import OS, I must use OS dot whatever method I want to use down below. If I use this method, I'm just importing this very small function. This will save a lot of saves a lot of RAM within your programs. Now, again, these are pretty small programs. It's not going to affect anything. But if you're coding where you need to really minimize the amount of storage and RAM that you're utilizing, you would just want to import the one function. If I import the entire random, I'm basically opening up all the different ones in there. If I want to be able to type any of those functions, I can use the word star, in which case I imported every random function available out of that module into my program, and therefore I can just reference it as randint. This will be important when you guys are building out bigger modules and you have more Python things towards the end of the semester. So knowing how to import all these is important. Again, always do your imports at the very top. So you should have your name up here, your 3 initial comments. Then you should have maybe a description of whatever you're doing. Then you should have your random or your imports always up here at the top. Then you can utilize those anywhere inside your code. All right. One of them that, see, I got a question here. What's the difference between import random versus random import star? The difference there is when you go to reference your random module, for example, here, if I use from random import star, I can just use randint down below here. If I say import random, then I must use random dot all the way through here and then go all the way through. It's usually better to do this method versus the star method. All right. The reason for that is that you now know that randint is tied to the random module. That's the benefit of using random dot whatever. Again, in this small program, it seems meaningless. When you start getting 1,000 lines of code, that makes more sense. No problem. All right, one other module we'll use is sys. And so with sys, one of the benefits of using that is to use sys.exit. Sys.exit will allow us to end the program at any point in time. All right, so if we're in the middle of this if-else loop, let's go ahead and uncomment this. If we say this is many years old and I don't want it to continue on with this code, I could break, or I could just use sys.exit here, in which case my sys.exit would replace the break. And at that point, the program itself will just end. It'll prompt up for the user to close out of the program. It just ends the program. All right. There is an exit or a quit that you could be using. It's better to use sys.exit anytime you want to force the user to end the program at that point. So if I run this code here, in which case my age is 65, it says I'm old, the program ends. It does not go down here and print JSON multiple times. If I do anything else, say 15, notice how it still goes through and prints all that numbers down here because it goes down to the next line of code. All right. That is going to be it for today in terms of this. We will come back and work through a couple of example programs that'll make a little more sense. And then we'll actually walk you through assignment 2 and how you guys are going to go through that. We'll do that on Wednesday. Anybody got any questions for this week? All right, if you haven't turned in your homework, some of you had some issues, sent me some emails over the weekend. I was swamped this weekend. So go ahead and turn those in as quickly as possible. I will get your homework graded. Hopefully I'll even have it graded by Wednesday so you guys have an idea of how you're doing and whether things are good, bad, that kind of stuff. All right. In that first one, remember, I'm kind of lenient on spelling, grammar, punctuation. From here on out, make sure you have that kind of stuff. All right. We'll work through this together on Wednesday. So if you show up on Wednesday, there's really no reason why you shouldn't have homework assignment 2 done as well. All right. Anybody have any issues with Python and getting it working this weekend that are here today? Yeah, I know yours there. Anybody else? All right. Again, if that happens, email me. I try to get back to you as soon as possible. Something comes up, just assume that I'll work with you the following week. The homework will not be counted as late for that. All right. We'll see you all on Wednesday.